సరే సార్ ఓకే.
మా ఆల్ ది స్టూడెంట్స్ వినిపిస్తుందండి?
ప్రోగ్రామ్ స్టార్ట్ అయ్యేటప్పుడు రికార్డింగ్
లైవ్ వెళ్ళిపోతుంది.
మొత్తం రికార్డ్ అయ్యింది అందులో.
హలో హలో
ఎస్ సార్ చెప్పండి.
ఓకే, very good morning to one and all. The session will start by sharp 11 o'clock. I request all the students, all second year students, please join immediately.
ఎస్ సార్. ఎస్ సార్ వినిపిస్తుంది.
మళ్ళీ రీకనెక్ట్ అవ్వండి. వస్తాయి ఇప్పుడు
ఆయన వచ్చిన సరే రాలేదు. ఫ్లైర్ పెట్టిండు.
తీసుకో
సార్ జాయిన్ అయ్యారా? ఓకే 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 ఓకే
ఇప్పుడు
మరి కనపట్లేదు ఏంటి? దాన్ని ఆంధ్రాకి వెళ్ళాను కదా వాళ్ళిద్దరికి తేజాకి
క్లయింట్ కార్డు
ఆగస్ట్ కాదు వాయిస్ ఏం షాప్ చాట్ డిసేబుల్ ఓకే సారీ సార్
జాయిన్ అయ్యా చూడు. హలో, నేను మ్యూట్ చేసుకోవాలా?
హిందీ వాళ్ళు కూడా
So, a very good morning to one and all. On behalf of Ignan Pharmacy College, I welcome you all to the 1 week student enhancement program on role of pharmacy teachers, a holistic approach to create an end product of education, be a free creative man. Now I request Pranati for further proceedings. Over to Pranati.
Thank you, sir. Miracles start to happen when you give as much energy to your dreams as you do to your fears. Good morning, everyone. With this positive attitude, I, Pranati, welcome you all to second day session on 1 week student enhancement program on role of pharmacy teachers, a holistic approach to create an end product of education, be a creative man, organized by Department of Pharmaceutical Analysis in association with IPA, AP State Branch, and VPCB Alumni Association. Without any further delay, let us move on to today's session by Dr. S. Nagarjuna Garu, Coordinator for Riper GPAT Cell, Hyderabad Academy, an online GPAT Academy, on the topic Electrophysiology of CVS and CVS disorders. I invite Tejasri to read out the profile of Dr. S. Nagarjuna Garu.
Thank you, Pranati. Good morning, all. I am Tejasri. I am honored to read out the profile of Dr. S. Nagarjuna Garu. He have total 11 years of academic experience and he is coordinator for NIPER GPAT Cell, Hyderabad Academy and Online GPAT Academy. His works were published in 10 international and 20 national publications. Dr. S. Nagarjuna Garu drafted 2 Indian patents and acted as a resource person and guest faculty for more than 20 institutions. Sir, we are privileged to have you here for today's session, sir. We request you to start your session.
Thank you. Thank you, one and all. Thank you.
Thank you, sir.
Shall I start, Ashok?
Yes, sir. Yes, sir.
No.
You can share the screen, sir.
A very good morning to all of you. It's happy to see my profile. And anyway, it's very glad to have this opportunity to share my knowledge to the budding pharmacists. And just now they given introduction that, and myself, Dr. Sannith Nagarjuna. So I am the coordinator for GPAT cell in Raghavendra Institute of Pharmacy, Anantapur. Plus, I am coordinating the Hyderabad Academy as well as online GPAT Academy. And I am so long associated with this Vignan College of Pharmacy. Anyway, I really thankful to the chairman of group of this Vignan group of institution, Mattaya Garu, principal of Vignan Pharmacy College, Srinivas Babu Garu, and organizing secretary for this program, Ashok Garu.
Thank you, sir.
So anyway, without much delay, so we'll move on to the topic for today's session, that is electrophysiology of cardiovascular system as well as the cardiovascular disorders. So mean to say that today we'll see actually what is the basic function of this cardiovascular system, how the impulse generation takes place, how impulse conduction takes place, what exactly mean by this heartbeat, ECG, and what is the definition for all these cardiovascular disorders, and how can you treat these conditions. Because I don't want to discuss much about pharmacology here, because they have instructed me to take majorly on the introductory report, because so many students belong to first year, second year, as well as Pharma D. Anyway, so one by one we'll go ahead slowly. Starts with the basics, then we'll go for the definition of disorders, reasons for disorders, and in what way we can treat the disorders. We'll see one by one. Fine. The first one, everyone knows that. So the cardiovascular system means, since from the 10+2 onwards we are studying that. So what is the importance of heart, what is the importance of blood, everything. We'll see somewhat in detail. The cardiac cycle, impulse generation, conduction, heartbeat, ECG, everything. So as we all know that there are three major components in the cardiovascular system. One is the heart, another is blood vessels, and there is blood. There are three major components present here: heart, another one blood vessels, the another one blood. And we all know that the heart is a device, the heart is an organ which is involved in pumping of blood. The blood vessels are those which are involved in supply or transport of blood. And what is the role of this blood? We all know that the blood is a carrier for the supply of oxygen, nutrients, and essential chemicals to all parts of the body. At the same time, the blood is also helpful to remove waste products from the body, like carbon dioxide. I hope you understand the respiration, breathing, exchange of gases. So we all know that inhalation of oxygen and exhalation of carbon dioxide. We continuously need inspiration, inhalation of oxygen. That oxygen will supply to all parts of our body. That all parts of the body will utilize this oxygen to perform their function. Then as a part of their function, cellular metabolism, they will release carbon dioxide as a waste product. So we need continuously the supply of oxygen and the removal of carbon dioxide This exchange of gases, the respiration, breathing also happens with the blood, with the help of blood system. So try to understand there are the three major components. What I'm telling you here is the heart is an organ which is majorly involved in the pumping of blood. The blood vessels are those which are involved in the supply, in the transportation of blood to various parts of the body. The blood is one which is a carrier for oxygen, not only the oxygen, which is a carrier for oxygen, nutrients, and essential chemicals to all parts of the body. At the same time, it will remove the waste products which are formed as a part of cellular metabolism. Let us go further. If we speak out briefly, the major functions of the cardiovascular system are, as we told just now, it is helpful for the transportation of nutrients, gases, and waste products around the body. So to protect the body from the infections and blood loss. Yes or no? Because the blood is having blood cells, red blood cells, white blood cells, platelets. Red blood cells are associated with the formation of hemoglobin. The hemoglobin is a major component for the supply of oxygen. White blood cells, also called as leukocytes, which are responsible or involved in the process of immunity. So that's why protect the body from infection. Next is platelets. Platelets, otherwise called as thrombocytes. The thrombocytes, platelets, majorly involved in the hemostasis, in the process of blood coagulation. So next, to help the body to maintain a constant body temperature, thermoregulation. So to maintain fluid balance within the body. So these are all the major functions of cardiovascular system. As I just now told you, transportation of oxygen, transportation of nutrients, transportation of essential chemicals, removal of waste products, protect the body from the infections for the process of immunity, to protect the body from blood loss, to avoid hemorrhage. As a part of hemostasis, majorly platelets, thrombocytes are involved, to maintain thermoregulation as well as to maintain fluid balance. So these are all the various major functions of the cardiovascular system. So next, and we all know that, simply speak that, just now mentioned it, the heart is a muscular organ which pumps blood through the blood vessels, and the pumped blood carries oxygen and nutrients to the body. The heart is a muscular organ which is a strong muscle which is located on the left side of the body in humans. And if you speak about blood vessels, just now I told you the blood vessels are involved in the transportation of blood throughout the human body for the transportation of oxygen, nutrients, and chemicals to all parts of the body, at the same time to remove waste products from the body. And for our understanding, we classified the blood vessels into two types. One is called as coronary blood vessels, and another is called as peripheral blood vessels. There are different classifications of blood vessels: arteries, veins, arterioles, venules, capillaries, likewise. But to understand these disorders, to understand these cardiovascular disorders, we just seen that we classified blood vessels into two types. One is called as coronary blood vessels, another is called as peripheral blood vessels. So what is this? One is called as coronary blood vessels, another is called as peripheral blood vessels. As everyone knows that from the name itself, coronary blood vessels means the blood vessels which supply blood to the heart. Peripheral blood vessels means periphery, the blood vessels which supply blood to various parts of the body. And further about this, we'll see in detail later. So simply to understand, the whatever the blood vessels which supply blood to the cardiac muscle, to the heart, are called as coronary blood vessels, which supply blood to various parts of the body is called as peripheral blood vessels. So with this, basic introduction of this cardiovascular system. Now we'll move on to the electrophysiology of the cardiac cell. We'll come to our exact point and discussion. We'll see what is this, the electrophysiology of the cardiac cell. So before going to this discussion, have a look onto this once again. I'm telling you, I'm repeating you for your better understanding. Cardiovascular system consists of heart, blood vessels, and blood. Heart is an organ involved in pumping of blood. Blood vessels are involved in transportation and supply of blood to all parts of the body. Blood is a one which is responsible for the supply of oxygen and removal of carbon dioxide in the body. Blood is having three major blood cells like red blood cells, white blood cells, platelets. Red blood cells, also called as erythrocytes, involved in the formation of hemoglobin, which is an essential component for the supply of oxygen. White blood cells, also called as leukocytes, involved in the process of immunity. Platelets, also called as thrombocytes, which are essential for the process of blood coagulation. And apart from the supply of oxygen, supply of nutrients, supply of essential chemicals, removal of waste products, the cardiovascular system also essential to maintain body temperature, called as thermoregulation, and to maintain fluid balance within the body. So now we'll move into that. To understand about all the cardiovascular disorders, everything, we should have some idea about electrophysiology of the cardiac cell. What exactly mean by this? We'll see one by one. So listen carefully. In this, the major important thing what you have to know here is the impulse generation. Nothing but action potential generation in the cardiac cell. So listen carefully. So here we are discussing the point called as impulse generation or action potential generation in the cardiac cell. As everyone knows that the basic property of cell in the body is that every cell in our body will generate the impulses, action potentials. So all the cells which is all cells which are present in the living state, usually they will generate the impulse, action potential. So right now we are talking about how impulse generation takes place in the cardiac cell. Always remember, the impulse is otherwise called as action potential. So listen carefully here. So first of all, we have a resting membrane potential. We know that RMP. So RMP means resting membrane potential. The resting membrane potential for the cardiac cell is minus 90 millivolts. So this resting membrane potential is varying from one cell to another cell. Here I'm talking about cardiac cell. The resting membrane potential for the cardiac cell is minus 90 millivolts. So from this resting membrane potential, whenever the cell reaches threshold potential, from this resting membrane potential, whenever the cell reaches threshold potential, the meaning of threshold potential is it is the minimum potential, it is the minimum energy required for impulse generation. Threshold potential means it is the minimum potential, it is the minimum energy required for impulse generation, which is approximately minus 70 millivolts. So remember carefully, resting membrane potential for cardiac cell is minus 90 millivolts. The cell is present at resting stage. Always at the resting stage, what are the ions present inside the cell is potassium. At the resting stage, what are the ions present outside the cell is sodium and calcium. Probably might have studied. Potassium is intracellular cation. Sodium is extracellular cation. Remember, I'm always speaking about at the resting stage. At the resting stage, the cardiac cell will maintain some potential which is called as resting membrane potential, which is approximately minus 90 millivolts. At this resting stage, potassium ions are present inside the cell. Sodium and calcium ions are present outside the cell. Just leave it. From this resting membrane potential, whenever the cell reaches threshold potential, from this resting membrane potential, whenever the cell reaches threshold potential, I'm telling you threshold potential means it is the minimum energy, the minimum potential required for impulse generation, which is approximately minus 70. That means at whenever cell reaches minus 70, threshold potential, minimum energy, now cell is able to generate the impulse generation. At minus 90, the cell is not in a position to generate the impulse. Whenever it reaches threshold potential, minimum energy minus 70 millivolts, the cell will start the impulse generation. Always, this impulse generation begins with the opening of sodium channels. Keep in mind always. Always, impulse generation begins with the opening of sodium channels. So whenever the sodium channels are opened, what happened? Just now I told you sodium is present outside, calcium is present outside, potassium is present inside. Always remember the impulse generation, action potential generation begins with the opening of sodium channels. Whenever sodium channels are open, there is an influx of sodium. There is an influx of sodium. So because of influx of sodium, sodium is entering into the cell. So sodium carries positive charge. So when the positively charged sodium ions enter into the cell, automatically cell potential will be increases. Am I right? Because sodium carries positive charge. See here. So because of the opening of sodium channels, there is an influx of sodium ions. As a result, potential will be increases. This is called as phase 0. These sodium ions enter into the cell at a very fast rate of 10 to the power of 7 sodium ions per second. So this is all about your phase 0. RMP, resting membrane potential, potential maintained at the resting stage, which is minus 90 millivolts. At the resting stage, potassium is present inside, sodium is present outside. Whenever cell reaches threshold potential, minimum energy for impulse generation, minus 70 millivolts, there is an opening of sodium channels. Whenever sodium channels open, there is an influx of sodium. Sodium ions enter into the cell at a rate of 10 to the power of 7 sodium ions per second. Because of the entry of sodium ions, because of the entry of positively charged sodium ions, potential will be increases. So this is all called as phase 0. You can see here. This is resting. This is called as phase 0. This is called as phase 0. Means potential will be increases, called as depolarization phase. Next. After this phase 0, what happened is, listen carefully, after some time, these sodium channels will be closed. After some time, the sodium channels will be closed. And then there is an opening of potassium channels. After some time, sodium channels will be closed. Then there is an opening of potassium channels. So because of the opening of potassium channels, what will happen? Potassium is present inside. So opening of potassium channels has efflux of potassium. Efflux of potassium means potassium enters outside the cell. Potassium carries positive charge. When the positively charged potassium ions enter outside the cell, the potential will be decreases. This is called as phase 1. So remember carefully, this is all very important. Whenever the sodium channels are closed, that is very important. Whenever the sodium channels are closed, after closing of these sodium channels, the potassium channels will be open. Opening of potassium channels causes efflux of potassium. Potassium will enter outside. So when the positively charged ions enter outside, potential will be decreases. This is called as phase 1. This is called as phase 1. If you want, have a look on this. See here. This is a phase 1. So this is phase 0. Whenever sodium channels are closed, opening of potassium channels, efflux of potassium, potential decreases. This is phase 1. Next, what happened? After this phase 1, and after some time, the calcium channels also will be opened. When the potassium channels are in the open state, that time only there is opening of calcium channels. When the calcium channels are open, what happened? There is an influx of calcium because calcium is present outside, right? So try to understand, when the potassium channels are in the open state, efflux of potassium takes place. Parallelly, simultaneously, there is an opening of calcium channels also. The opening of calcium channels causes influx of calcium. Now, what are the things happening here? Potassium channels are in the open state, calcium channels are in the open state. Efflux of potassium, influx of calcium. Potassium is entering outside, calcium is entering inside. So one positively charged ion is entering outside, another positively charged ion is entering inside. So potential will be balanced. There is no change in the potential. See here, the influx of calcium and efflux of potassium. So the influx of one positively charged ion and efflux of another positively charged ion. So hence there is no change in the potential. We observed as a plateau phase. That is called as phase 2. After phase 1, we have a phase 2, plateau phase. No change in the potential. Have a look on this. This is a phase 2. No change in the potential. Influx of calcium, efflux of potassium. Right. Finally, after this phase 2, next, phase 3. In phase 3, what happens is, after sometime means always, it is all milliseconds. All happens within a just span of milliseconds. After some time, these calcium channels will be closed. So if the calcium channels will be closed, what happened? There is only potassium channels will be in the open state, right? Because in the phase 2, opening of potassium, opening of calcium channels is observed. After some time, calcium channels will be closed means we observe only potassium channels in the open state. When the potassium channels are in the open state, what happened? Efflux of potassium, the continuous efflux of potassium means potassium enter outside. When the positively charged ions enter outside, automatically potential will be decreases. This is called as phase 3. This is called as phase 3. Have a look on this. This is phase 2, no change. Now, will be only open of potassium, efflux of potassium, potential will be decreases. This is called as phase 3. We call as repolarization. Next. And finally, if you see this phase 3, what we observe? At phase 3, what is happening? Continuous efflux of potassium means potassium is present outside. Sodium is present inside. Is it not? At phase 3, I'm talking to you. Please listen carefully. Little bit confusion will be there here. In phase 3, what I told you, there is a continuous efflux of potassium. So that at the phase 3, what happened? Potassium is present outside. Sodium is present inside, because at phase 0, sodium enter inside. But actually what I told you, always at the resting stage, potassium ions are present inside the cell, sodium ions are present outside the cell. This is the original position of ions. This is the actual position of ions. Potassium has to present inside, sodium has to present outside. But here at the phase 3, they are present in the opposite directions. That time, there is an activation of the enzyme Na plus K plus ATPase. There is an activation of the enzyme Na plus K plus ATPase. Probably might have studied about this Na plus K plus ATPase in biochemistry so many times. What this Na plus K plus ATPase will do is, which will keep potassium inside and sodium outside. The role of this sodium potassium ATPase is, which will keep potassium inside and sodium outside. And once again, the cell reaches the resting state, which is called as phase 4. So there is an activation of enzyme Na plus K plus ATPase, which will keep potassium inside and sodium outside. Once again, cell reaches resting state, which is a phase 4. So the cell begins with the resting state. Once again, cell reaches the resting state. So always keep in mind, impulse generation takes place at the resting stage. Once again, the cell reaches the resting stage. Likewise, the cells are continuously generating the impulse. Begins with the resting, reaches the resting once again. Listen carefully, totally 5 phases are there. Starts with the phase 0. So don't consider as 4. We have to consider 0 also. So totally 5 phases. Phase 0, 1, 2, 3, 4. See, have a look on this. This is phase. This is the resting. Phase 0, 1, 2, 3, 4. Resting, phase 0, 1, 2, 3, 4. Once again, cell reaches the resting. Once again, cell will generate the impulse. The cells will always generate the impulse when they are present at the resting stage. Cells will always generate the impulse always when they are present at the resting stage. So have a look on this one by one. Once again, have a look on this. Listen carefully. If you understand this, you can understand cardiovascular system very easily. So once again, have a look on this carefully. See, right now I'm talking about you. Impulse generation, action potential generation in the cardiac cell. How it takes place is, first of all, the resting membrane potential for the cardiac cell is minus 90 millivolts. So resting membrane potential means the potential which is maintained at the resting stage. When the cardiac cell is present at the resting stage, it will maintain a potential called as resting membrane potential, which is approximately minus 90 millivolts. Always at the resting stage, you remember, potassium ions are present inside the cell. Sodium and calcium ions are present outside the cell. Whenever the cell from the resting membrane potential reaches the threshold potential means minimum energy, minimum potential for impulse generation, which is approximately minus 70 millivolts. Whenever cardiac cell reaches minus 70 millivolts, threshold potential, minimum energy, it will start the impulse generation. Always impulse generation begins with the opening of sodium channels. Whenever the sodium channels will be opened, the sodium ions enter into the cell at a very faster rate of 10 to the power of 7 sodium ions per second. Because of the entry of the positively charged sodium ions, the potential will be increases. This is called as phase 0. And after some time, milliseconds, these sodium channels will be closed. Whenever sodium channels are closed, then there is an opening of potassium channels. The opening of potassium channels causes efflux of potassium. Potassium will enter outside. When the positively charged potassium ions enter outside the cell, potential will be decreases. This is called as phase 1. When the potassium channels are in the open stage, efflux of potassium is taking place. Simultaneously, there is an opening of calcium channels also that causes influx of calcium. Now, simultaneously, there is an influx of calcium and efflux of potassium. Influx of one positively charged ion, efflux of another positively charged ion. As a result, there is no change in the potential called as plateau phase, which is called as phase 2. Then within a short time, the calcium channels will be closed. Only potassium channels will be present in the open state. There is a continuous efflux of potassium ions that causes a decrease in the potential, which is called as phase 3. And finally, at this stage, potassium is present outside, sodium is present inside, present in opposite directions. So finally, there is an activation of the enzyme called as Na plus K plus ATPase. The enzyme which will keep potassium inside and sodium outside once again cell reaches resting state, which is called as phase 4. So this is the thing what you have to understand, how the cardiac cell will generate the impulse. Begins with the resting, finally reaches the resting. So this is the resting. Phase 0, 1, 2, 3, 4. Phase 0, sorry, resting, minus 90 millivolts. This is lines, threshold potential, minus 70. Opening of sodium channels, phase 0, potential increases. Sodium channels closed, opening of potassium, efflux of potassium, decrease in the potential, phase 1. Next, opening of calcium channels, influx of calcium, efflux of potassium, no change in the potential, phase 2. Closing of calcium channels, only efflux of potassium, decrease in the potential, phase 3. Activation of sodium potassium ATPase, maintain resting, phase 4. So it should be in your fingertips always, I'm telling you. Resting, phase 0, phase 1, phase 2, phase 3, phase 4. Yeah, if you want, you can see one sign here also. The resting stage, phase 0, phase 1, phase 2, phase 3, phase 4. This is the resting, minus 90. Opening of sodium channels, opening of potassium channels, opening of calcium channels, opening of only potassium channels, activation of Na plus K plus ATPase. Finally, one should have an idea about this. See here. 4, resting, 4. So 1, 2, 3, 4. I'm always telling you the 5 phases. 5 phases. Starts with the 0 phase. So 0 phase, 1, 2, 3, 4. This is sodium channel opening, depolarization. This is potassium channel opening. This is plateau phase. This is repolarization. This is resting state. Finally, you remember, this is very important. And the which phases will occur because of which ion channel opening. This is the most important thing you should know. So what I told you here, there are 5 phases. What are those? 0, 1, 2, 3, 4. The phase 0, because of the opening of sodium channels. Phase 1, because of the opening of potassium channels. The phase 2, plateau phase, because of the opening of calcium channels. Phase 3, because of the opening of potassium channels. And phase 4, because of the activation of Na plus K plus ATPase. This is very important to remember, please. 5 phases, 0, 1, 2, 3, 4. 0, opening of sodium channels. 1, opening of potassium channels. 2, opening of calcium channels. 3, opening of potassium channels. 4, because of the activation of Na plus K plus ATPase. So this is all called as impulse generation, action potential generation in the cardiac cell. I'm always telling you the cells will generate the impulses only when they are present at the resting stage. That is most important thing you should remember. The cells will generate the impulses only when they are present at the resting stage. So that's why I'm telling you the cell is present at the resting stage. It will generate the impulse. Once again, cell should come back to the resting stage. This resting stage is essential for further impulse generation. So without reaching the resting stage, the cell is not ready for the impulse generation in the next cycle. So likewise, the cardiac cells are continuously generating the impulses, action potentials, when they are present at the resting stage. And what is the importance actually? And what is the significance of this impulse generation? Why do we require this impulse generation? What happens because of this impulse generation? We'll see one day. So after this impulse generation, you people have to know about impulse conduction. So nothing but impulse propagation in the cardiac cell. After the impulse generation, as you know that the common reactions about impulse generation, conduction. Impulse generation, impulse conduction, right? After the generation of impulse, now we'll speak about impulse conduction in the cardiac cell. How the impulse is conducted, transmitted from one area to another area. Actually, where this impulse is generating, to where it is conducting, what happens because of this conduction, and what it contributes, everything we'll see here. So before that, see, we have a word and definition called as automaticity. So we have a word called as automaticity. From the name itself, you can easily understand what do you mean by automaticity. Automaticity means automatic. Automaticity means automatic. Means, see here, the capacity to generate the action potential. I'm repeatedly telling you action potential is nothing but impulse. Impulse is nothing but action potential. So capacity to generate action potential on its own without any external stimulus, called as automaticity. So the meaning of automaticity is automatically the capacity to generate the impulse, capacity to generate the action potential on its own without any help, without any support, without any external stimulus, which is called as automaticity. Automatically, the things will generate the impulse. That phenomenon is called as automaticity. Who is having that automaticity is SCA node, as you know that. The sinoatrial node, SCA node, is having the property of automaticity. Henceforth, this SCA node is otherwise called as pacemaker of the cardiac cell. This SCA node is called as pacemaker of the cardiac cell. Okay, listen. Automaticity, capacity to generate the impulse automatically without any help, without any support, without any external stimulus. Who is having this automaticity is SCA node. Hence, it is called as a pacemaker of the cardiac cell. Now, what happens after the impulse generation? Now, what happens after this impulse generation? See here. The first, as you mentioned here, I think you might have studied several times, the normal impulse conduction pathway. The first is SCA node, having automaticity, pacemaker. The impulse generation takes place in the SCA node. From this SCA node, what happened? The impulse transmits to atria, atria to AV node, AV node to bundle office to Purkinje fibers to ventricles. This is called as one complete impulse conduction. Always remember the origin point is SCA node, the end point is ventricles. SCA node is having automaticity, generate the impulse automatically, own without any support, without any help. From this SCA node, impulse transmits to atria, atria to AV node to bundle office to Purkinje fibers, finally to ventricles. And because of all these things, what will happen? The impulse reaches to ventricles. Whenever impulse reaches to ventricles, what happened? The ventricles undergo contraction. That results in ventricular contraction. Is it right? Whenever impulse reaches to ventricles, that leads to ventricular contraction. Ventricular contraction means nothing but what? It's nothing but heartbeat. It's nothing but heartbeat. As we discussed, the role of heart is pumping of blood. Heart is involved in pumping of blood means, exactly speak that who is pumping the blood? As you all know that there are 4 chambers present in the heart, the 2 atria and 2 ventricles. Right atria, right ventricle, left atrium, left ventricle. Exactly speaking that heart is pumping the blood to various parts of the body means, who is pumping the blood actually? Ventricles, especially speak that left ventricle. So ventricular contraction, nothing but the heartbeat, heart pumps. So whenever we have an impulse generation and impulse conduction, we'll observe heartbeat. The heart is there. One time heart is beating. Please try to understand. Heartbeat is nothing but, the reason for the heartbeat is nothing but one complete impulse conduction to the ventricles. Whenever we have an impulse conduction to the ventricles, we'll observe heartbeat. So remember, always remember, in the heart, in the cardiac cell, we have a SCA node. SCA node will generate the impulse called as pacemaker. From the SCA node, impulse moves to atria, AV node, bundle office, Purkinje fibers, ventricles. When impulse reaches to the ventricles, ventricles undergo contraction, that is called as heartbeat. You remember scientifically, heart is beating. When heartbeat is coming is nothing but one impulse generation and impulse conduction. The reason behind this heartbeat is nothing but impulse conduction. I'm telling you one impulse conduction. The impulse should reach the ventricles. Then only we observe the heartbeat. impulse should reach the ventricles. Then only you will observe the heartbeat. So move on to this. The SCA node pacemaker, atria, AV node, bundle of his Purkinje fibers, ventricles. So move on to this ECG, nothing but electrocardiogram. And we all know that the ECG is nothing but heartbeat. Remember carefully. So don't feel that and don't expect that heart ECG is something different. ECG means somewhat different thing, nothing else. The simplest way to understand ECG is heartbeat. Heartbeat and ECG both are same. Listen carefully. The heartbeat and ECG both are same. We are listening the heartbeats with the help of the stethoscope, and we are visualizing the heartbeats in the form of ECG. The ECG is nothing but the visual presentation of the heart, electrocardiogram. And if you see this ECG, each and every line, each and every wave will have certain meaning, which gives you some information. What is that you'll see here? Listen carefully, I'm telling you here. You people should be in a position based upon the ECG, you should understand how impulse conduction is taking place. At the end, I will show you some videos also regarding this impulse generation conduction. You will get some more realistic approach. Have a look on this. What I would like to say you here is, this ECG is nothing but heartbeat, nothing but impulse conduction. By seeing the ECG, you should be in a position to identify how impulse conduction is taking place. So let us have a look onto this. This first line, remember carefully, this first line is because of SCA node. Is because of SCA node. Whenever impulse generation takes place in the SCA node, we observe this line. In the ECG, this line indicates SCA node depolarization. From the SCA node, impulse moves to atria. So this line indicates atrial depolarization, P wave. So next, from the atria, impulse moves to AV node. This is because of AV node. This line is because of AV node. From the AV node, impulse moves to bundle of his Purkinje fibers. So bundle of his Purkinje fibers are also part of ventricles. The impulse reaches to the ventricles, and these ventricles undergo contraction. This QRS complex is ventricular contraction. And finally, I told you the ventricles are the last parts involved in the impulse conduction. So ventricular contraction followed by ventricular relaxation, ventricular depolarization followed by ventricular repolarization. This is represented by T wave up to here only. I'm telling you here only. This is called as one impulse conduction, one heartbeat, one ECG. This is SCA node, atria, AV node, ventricular contraction, ventricular relaxation. This is called as one ECG, one heartbeat, one impulse conduction. What is this once again? This is once again SCA node. Likewise, how many ECGs will be there? 72 ECGs. Simply, that's what I'm telling you repeatedly. The ECG is nothing but heartbeat. Heartbeat is nothing but ECG. The normal heartbeat is 72 beats per minute. So how many ECGs will be there in a minute? 72 ECGs will be there. But heartbeat, you are just listening. But ECG, you are visualizing how heartbeat is coming, how impulse conduction is taking place. See here point, the SCA node, atria, AV node, ventricular depolarization, ventricular repolarization. This is one sign SC node. This is another heartbeat. This is another ECG. But if you observe this ECG, out of these all things, this QRS complex is very big. Out of all these complexes, this QRS complex is very large, very big. Why is, compared to the all areas of heart, the ventricles have more calcium channels, more contraction capacity. The ventricles have more contraction capacity. Because of the more contraction capacity of the ventricles, the QRS complex will be observed in a big complex way. So now try to understand, this is the SCA node, atria, AV node, ventricular contraction, ventricular relaxation. So this is called as one impulse generation, one impulse conduction, one heartbeat, one ECG. So what is the purpose of taking ECGs actually? Just now we are telling that heartbeat and ECG both are same. We are listening the heartbeats and we are visualizing the heartbeats in the form of ECG. We are listening the heartbeats, we are seeing the ECG. Why should we go for ECG? Why should we go for ECG? Means with the help of heartbeats, based upon the number of heartbeats, we can only say that whether person is having a problem or not. Suppose normal heartbeat is 72 beats per minute. Suppose he is having 150 beats or 120 beats per minute, you can say that you have a problem in the heartbeat. But you cannot say that where the problem is taking place and what is the reason for the problem. And based upon the ECG, you can identify that where that problem is taking place. Based upon the ECG, you can identify that where that problem is taking place. Suppose if you take the ECG, if there is a disturbance in the QRS complex, that indicates a problem in the ventricles. Suppose there is a disturbance in the P wave, that indicates a problem in the atria. If you have a disturbance in the first line, that indicates there is a problem in the SCA node. Likewise, the purpose of ECG is to identify the location where the problem is taking place, to identify the location where the abnormality is taking place. So this is called as the ECG, electrocardiogram, heartbeat, impulse generation, impulse conduction. So remember carefully here, I would like to tell you here, the first point is impulse generation. Impulse generation includes 5 phases, 0, 1, 2, 3, 4. This is the opening of sodium channels, potassium channels, calcium channels, potassium channels, Na plus, K plus, ATPase, maintain resting stage. Always cells will generate the impulse at the resting stage. Who is having this impulse generation property is SCA node, which is having automaticity, which is called as a pacemaker. After the generation of impulse by the SCA node, the impulse will be conducted to atria, AV node, bundle of his Purkinje fibers, ventricles. Because of one complete impulse conduction to the ventricles, ventricles undergo contraction, nothing but a heartbeat. We can observe an ECG. In the ECG, the first line is SCA node. This is atria, AV node, ventricular contraction and ventricular relaxation. And if you observe technically, actually, finally point, what I would like to tell you is, one impulse generation, one impulse conduction, one heartbeat, one ECG. If you see here, what is the normal heartbeat? 72 beats per minute. What is the normal heartbeat? 72 beats per minute. Yes or no? 72 beats per minute means 72 beats per 60 seconds. Normal heartbeat is 72 beats per minute. So that 72 beats per 60 seconds. Per 60 seconds, 72 beats are coming. 72 times heart is beating means 72 times impulse is conducting. Yes or no? 72 times 72 beats per 60 seconds means 72 times heart is beating per 60 seconds. 72 times heart is beating means 72 times impulse is conducting. I told you repeatedly, one impulse generation, one impulse conduction, one heartbeat. 72 beats means 72 times impulse conduction per 60 seconds. Based on this, can you tell me what is the normal time required for one impulse conduction? You can easily say that, right? 72 beats per 60 seconds. 72 times impulse conduction per 60 seconds. So that what is the time required for one impulse conduction? You can easily say that it is more than 1 second or less than 1 second. It is less than 1 second. Is it clear? That is nothing but 0.8 seconds. That is what you are studying, that cardiac cycle. The time taken for one impulse conduction from SANO to the ventricles is 0.8 seconds. So that we observe normal heartbeat as 72 beats per minute. What you people have to understand here is 72 beats per minute is not a constant parameter. Which is constant? The time taken for impulse conduction is 0.8 seconds. That is correct. That is constant. The time taken for one impulse conduction from SNO to ventricles is 0.8 seconds, so that the number of heartbeats will be 72 beats per minute. You just assume it. If the time taken for impulse conduction is 1 second, how many heartbeats will come? 60 beats will come. So here the number of beats is not important. The important parameter is the time for cardiac cycle, the time for one impulse conduction. The normal time required for one impulse conduction is 0.8 seconds, so that the number of heartbeats will be 72 beats per minute. So this is all about the impulse generation, impulse conduction, heartbeat, ECG, cardiac cycle time. And after this, next we'll move on to the next area of this cardiovascular system, the flow of blood in the chambers of heart. Right now we are all speaking about impulse, generation, conduction, heartbeat, ECG, cardiac cycle time, everything. And now we'll speak about the flow of blood in the chambers of heart, how the flow of blood takes place and how it is involved. What are the valves involved? What are the blood vessels involved? Everything we'll have a look on this. So if you understand this flow of blood in the chambers of heart, so you can understand the total cardiac cycle, what exactly happening in the cardiac cell. Then you can easily understand what are the cardiovascular disorders, what are the problems related to the cardiovascular system. One basic parameter is over, one basic understanding is over. Impulse, generation, conduction, heartbeat, ECG, cardiac cycle time. What do you mean by heartbeat? And why we are observing heartbeat as 72 beats per minute? What is automaticity, conduction pathways, everything. The next, the basic parameter you people have to know is flow of blood in the chambers of heart. If you know these things also, and all together, which is very much helpful to understand the cardiovascular disorders, that will go ahead after this. Okay, fine. Just 2 minutes, just take your refreshments, just 2 minutes. Okay, I'll take some water and I will come back. So all of you come back to the discussion. So now we'll see the flow of blood in the chambers of heart, from where the heart is getting blood and how the heart is pumping the blood, everything we'll see. And as you all know that there are 4 chambers of the heart, 2 atria and 2 ventricles. The upper chambers are called as atria, the lower chambers are called as ventricles. Upper chambers are called as atria and lower chambers are called as ventricles. The smaller chambers are called as atria and the larger chambers are called as ventricles. So coming to the point here, first of all, the blood will reach us to the right atrium. I think everyone knows that. So what type of blood will come usually? Deoxygenated blood, impure blood. Is it not? Have a look onto this. So what are the blood vessels will carry? Superior vena cava and inferior vena cava. Listen carefully. Superior vena cava carry blood from upper extremes of the body. Inferior vena cava carry blood from lower extremes of the body. From all parts of the body, superior vena cava, inferior vena cava carry deoxygenated, impure blood into right atrium. Then, from the right atrium, blood enters into right ventricle. So upon the opening of a valve called as tricuspid valve. Tricuspid valve means the valve made up of 3 flaps, 3 cusps. Tricuspid cusps, 3 cusps or 3 flaps. So blood reaches to the right ventricle. From the right ventricle, the blood will reach us to the lungs through pulmonary artery. As you know that in the lungs, blood undergo purification. As you know that the lungs are the organs of respiration. Respiration means exchange of gases, purification of blood, inhalation of oxygen, exhalation of carbon dioxide. So the blood gets purified. So from that, the oxygenated blood, the purified blood will enter into the left atrium. The left atrium pump the blood into left ventricle. Upon the opening of a valve called as bicuspid valve, called as mitral valve, made up of 2 flaps, 2 cusps, also called as mitral valve, the blood reaches to left ventricle. Finally, this left ventricle will pump the blood to various parts of the body. What type of blood? Oxygenated blood. In a brief, in a simplified way, I'm telling you here. One sentence go further. Superior vena cava from upper extremes of the body. Inferior vena cava from lower extremes of the body. Overall, from all areas of the body, these blood vessels carry deoxygenated blood, impure blood into right atrium. From the right atrium, blood enters into right ventricle. It reaches to lungs. Blood undergoes purification. The purified oxygenated blood enters into left atrium, reaches to left ventricle. Finally, left ventricle pump oxygenated purified blood to various parts of the body. So this is how the heart is receiving the impure blood and the heart is pumping the pure blood. This is how the heart is receiving the deoxygenated blood and the heart is pumping oxygenated blood. And how exactly the valves involved here, you can see further. So listen carefully. First, see here, superior vena cava. Superior vena cava. One, from the upper extremes of the body. See here, two, inferior vena cava, from lower extremes of the body. Both will carry blood into right atrium. This is the third. 1 and 2 will bring blood into third one, right atrium. What kind of blood? Deoxygenated, impure blood. Next, from this right atrium, the blood will move to right ventricle through the opening of a valve. This is the 4 tricuspid valve, made up of 3 flaps, 3 cusps. Blood moves from right atrium to right ventricle. 3, 4, 5. Blood is there in the right ventricle now. Now 5th to, I mean to say that 5 to, the right ventricle pump the blood into this pulmonary artery. Here also there is a valve present called as pulmonary valve. One more point, pulmonary valve. So upon the opening of a pulmonary valve, the blood will go to pulmonary artery, nothing but into the lungs. Then this in the lungs, the blood will undergo purification. The pulmonary veins will carry that oxygenated purified blood into the left atrium. And as usually this left atrium pump the blood into left ventricle through the opening of a mitral valve, bicuspid valve. This is at 10-11. And finally, we all know that the left ventricle pump the blood into various parts of the body through systemic aorta, through a opening of a valve called as aortic valve. Whenever left ventricle pump the blood, there is an opening of aortic valve. Blood comes to aorta, supply blood to various parts of the body. I hope you understand. With the numbers, you can easily understand. All they have mentioned very sequentially. So totally the 13, please. Once again listen. 1, superior vena cava. 2, inferior vena cava. Carry impure blood into third one, right atrium. So right atrium pump the blood into right ventricle, opening of tricuspid valve, 4th one. Blood comes to right ventricle. Right ventricle will pump the blood into lungs through a opening of valve called as pulmonary valve. Then from the lungs, after purification, the blood will reach to left atrium. Then finally the left atrium pump the blood into left ventricle through a opening of mitral valve, bicuspid valve. Finally, this left ventricle is a part of the heart responsible for pumping of blood into various parts of the body through aorta by opening of a valve called as aortic valve. So 12 and 13. So try to understand there are totally 4 valves present. There are 4 valves present. Tricuspid valve, bicuspid valve, pulmonary valve, aortic valve. So listen carefully. The tricuspid valve in between right atrium to right ventricle. Upon the opening of tricuspid valve, blood will move from right atrium to right ventricle. Next is a pulmonary valve. Due to opening of a pulmonary valve, right ventricle pump the blood into lungs. Next is bicuspid valve, mitral valve. The left atrium pump the blood into left ventricle through the opening of a bicuspid valve. Finally, aortic valve. The left ventricle will pump the blood into aorta to various parts of the body through opening of aortic valve. Now listen carefully. Now you combine this impulse generation conduction with the flow of blood. Now you mix together. Now you combine this impulse conduction with the flow of blood in the chambers of heart. Yeah, now point. First one, what happened? Always remember the right and left chambers of the heart will work together. This is most important, you should remember. Operating at the same time at the right and left chambers of the heart will operate at the same time. Don't think that after this after this. So all the things will work together. Yes or no? Now you combine this impulse conduction with the flow of blood. First, what happened? Tell me. Impulse generation takes place in SNO, automaticity, pacemaker. Yes. From the SNO, impulse moves to atria. If impulse moves to atria, what happened? Atria undergo contraction. Atria undergo contraction. Because of atrial contraction, pressure in the atria will increase. Because of atrial contraction, pressure in the atria will increase. Whenever pressure in the atria will increase, what happened? The valves get open. There is an opening of tricuspid valve. There is opening of bicuspid valve. Blood moves from right atrium to right ventricle. Blood moves from left atrium to left ventricle. Next, what happened? Parallelly, the impulse move from atria to AV node, bundle of his, Purkinje fibers, ventricles. Finally, ventricles undergo contraction, more powerful contraction. Whenever the ventricles undergo contraction, what happened? Pressure in the ventricles will increase. Because of ventricular contraction, pressure in the ventricles will increase. Whenever pressure in the ventricles will increase, first, there is a closing of tricuspid valve and there is a closing of bicuspid valve. Why? To avoid backflow of blood. As everyone knows that the blood should move only in a unidirectional, in single direction. At any cost, there is no backflow of blood into the chambers of heart. So whenever the ventricles undergo contraction, pressure in the ventricles will increase. First, there is a closing of tricuspid valve and closing of bicuspid valve. After that, there is an opening of pulmonary valve and opening of aortic valve. Then the blood will move to lungs, then blood will move to aorta. As usual, it reaches to various parts of the body. This is all you have to understand. The impulse generation, impulse conduction will work in parallelity with the flow of blood in the chambers of heart. Once I'm repeating you, impulse generation in the SNO moves to atria. Atria undergo contraction. Whenever atria undergo contraction, the pressure in the atria will increase. Whenever pressure in the atria will increase, there is an opening of bicuspid valve. Blood will move from right atrium to right ventricle, left atrium to left ventricle. Then simultaneously, the impulse will move from atria to AV node, bundle of his, Purkinje fibers, ventricles. Whenever impulse reaches to ventricles, ventricles undergo contraction. Whenever the ventricular contraction, pressure in the ventricles increase, closing of tricuspid valve, bicuspid valve, then there is opening of pulmonary valve, aortic valve. The blood will enter into lungs and blood will reach to other parts of the body. These entire things are called as cardiac cycle, called as 0.8 seconds. Within this 0.8 seconds, impulse generation takes place, conduction takes place, blood is moving, and finally heart will pump the blood to all parts of the body. So remember here, there are two aspects here. One is heart is beating. When the heart is beating, the heart is pumping the blood to all parts of the body. Heart, in order to pump the blood, first heart has to beat. For that to beat, what you require? Impulse generation and conduction. Whenever impulse generation conduction takes place, then only heart will beat. When the heart beats, it has to pump the blood to all parts of the body. For that, we require flow of blood. Simply blood is flowing, blood is coming to left ventricle, but if the heartbeat is not there, the blood is not come out of the heart, right? The heart is not able to pump the blood. Here, impulse generation conduction is involved in response for pumping, beating Because of beating, blood will come out of the heart and reach into all parts of the body. But because of impulse generation conduction, heart is beating. When the heart is beating, blood has to come out. For that, blood has to circulate in the chambers of heart. So always, all these sequence, all these steps will work together in pumping of blood to various parts of the body. This is totally called as circulatory system. Supply of oxygen, supply of nutrients, pumping of blood, transportation of blood, supply of blood, impulse generation, conduction, heartbeat, ECG, cardiac cycle. Totally 0.8 seconds. So the same thing, whatever I mentioned you, they have mentioned here, same thing. Right side, left side, what happens? And finally, now with this basic introduction and fundamental of this cardiovascular system, so next we'll move on to the disorders related to this cardiovascular system. As our topic has told you, the electrophysiology of cardiovascular system and cardiovascular disorders. So now with this basic understanding and introduction to this cardiovascular system, so now we'll move on to the disorders of cardiovascular system. So I'm not going to explain you in very much detail because I'm not talking about pharmacology here. Just I would like to give you some idea about what is the definition of these disorders and what is going to happen in these conditions. So let us have a look onto these disorders related to cardiovascular system. The meaning of disorder is altered function. As of just now, we have all discussed what is a normal function. Now we'll move on to the disorder, altered function. What are the names of those disorders? What is going to happen in that condition? And how can you treat that condition in a brief manner? The first disorder you people have to know is arrhythmias. What is this? Arrhythmias. So arrhythmias means everyone knows that abnormal heartbeat or irregular heartbeat. The heartbeat maybe increases or decreases. The normal heartbeat is 72 beats per minute, but no individual should have 72 beats per minute at all times. The number of heartbeat is highly variable. It is varying from one time to another time based upon your sleep pattern, stress pattern, body posture, the type of food what you taken, everything will decide your number of heartbeats. But the normally acceptable heartbeat range is 60 to 100 beats per minute. Irregular or abnormal heartbeat called as arrhythmias. Heartbeat increases or decreases. 72 beats per minute. Acceptable range is 60 to 100 beats per minute. And basically these arrhythmias are of two types, bradyarrhythmias and tachyarrhythmias. So I just now told you tachyarrhythmias means increase in the heartbeat above 100 beats per minute. Bradyarrhythmias means decrease in the heartbeat less than 60 beats per minute. Now we'll go one by one. Exactly what are the reasons for these conditions actually. So tachyarrhythmias, increased heartbeat. As I just now told you, what is the reason for a heartbeat? Repeatedly I'm telling you, impulse generation, impulse conduction, ventricular contraction, heartbeat, ECG, all are nothing but same. One impulse generation, conduction, heartbeat, ECG, same. But tachyarrhythmias means people are having increased heartbeat. The heartbeat is increasing. So based upon all our introduction fundamentals and all, easily you can understand why people will have increase in the heartbeat. Yes or no? So what are the reasons for increase in the heartbeat is, first one, increased impulse generation SCA node. Am I right? If you have more impulse generation SCA node, automatically there is more number of heartbeats. Yes, sir. If more generation of impulses, more impulse conduction, more heartbeats. So the major reason for increase in heartbeat tachyarrhythmias is increased impulse generation SCA node, which observed because of excess activation of sympathetic nervous system. As you know that sympathetic and parasympathetic both are innervated to SCA node, both should be in the balance. But because of the excessive activation of sympathetic nervous system, we can see the more impulse generation SCA node. That is what the reason for tachyarrhythmia. Next, fast impulse conduction. Yes, sir. What is the normal impulse conduction time? 0.8 seconds. If the time required for impulse conduction decreases, if impulse is conducted fast, automatically number of heartbeats will be increases. Yes or no? Normally it requires 0.8 seconds from SCA node to ventricle so that we have 72 beats. If impulse is conducting fast, the time required will be decreases. When the time decreases, automatically number of impulses will be increases. And the third one is echotopic foci. Echotopic foci means apart from the SCA node, other parts also have the property of automaticity. And normally, SCA node is a pacemaker which only should have the property of automaticity. Yes or no? But because of some genetical differences, genetical variations, apart from the SCA node, other parts also exhibit the property of automaticity, which is called as echotopic foci. So these are all the reasons for tachyarrhythmias. Increased impulse generation SCA node, fast impulse conduction, echotopic foci. Next, bradyarrhythmias. Bradyarrhythmias, decrease in the number of heartbeats. Same, opposite to tachyarrhythmias. So decreased impulse generation SCA node because of overactivation of parasympathetic nervous system. Slow impulse conduction, time required will be increases. Third one is heart block. Heart block means blockade in any part of the cardiac cell. Results in failure of impulse conduction to the ventricles. Yes or no? Because I told you already, this is the normal impulse conduction. Heart block means the heart blockade takes place in any one part, results in failure of conduction to the ventricles, lead to decrease in the number of heartbeats. Not permanent blockade, not complete blockade, I'm telling partial blockade. If suppose blockade takes place in the AV node, there is no further conduction of impulse to the ventricles, automatically heartbeats will be decreases. I'm not telling permanent blockade, partial blockade. So these are all the reasons for tachyarrhythmias and bradyarrhythmias. And if you see, and what kind of mechanisms are suggested to treat arrhythmias based on all this discussion? Just now I told you, arrhythmias are decreased or increased heartbeat. Decreased heartbeat called as bradyarrhythmias, increased heartbeat called as tachyarrhythmias. But most of the patients, 99% of the patients are suffering from tachyarrhythmias. So how will you treat the tachyarrhythmias? By using the drugs called as antiarrhythmics. And whatever the drugs we are seeing in the textbooks, the antiarrhythmics are for the treatment of tachyarrhythmias. How can you treat the tachyarrhythmias? Can you tell me? Now a person is suffering from tachyarrhythmias. A person is suffering from tachyarrhythmias. Person is suffering from tachyarrhythmias means person is having increased heartbeat. How will you treat tachyarrhythmias? By decreasing the heartbeat. How will you decrease the heartbeat? By decreasing impulse conduction. By decreasing impulse generation. Yes or no? If you decrease impulse generation, impulse conduction will be decreases. Automatically number of heartbeats will be decreases. And how will you decrease impulse generation? We told you how impulse generation takes place by using the phases. Yeah. What are the phases? 0, 1, 2, 3, 4. How will you inhibit this zero phase? By using sodium channel blockers. How will you inhibit 1 and 3 phase? By using potassium channel blockers. How will you inhibit the second phase? By using calcium channel blockers. So this is what all the mechanisms we have for the treatment of tachyarrhythmias. Keep in mind, very clearly I'm telling you, the person is suffering from tachyarrhythmias. The person is suffering from increased heartbeat. How will you treat this tachyarrhythmias? By decreasing the heartbeat. How will you decrease the heartbeat? By decreasing impulse conduction, by decreasing impulse generation. How will you decrease impulse generation? By inhibiting the phases which are involved in the impulse generation. So we are inhibiting the zero phase by using sodium channel blockers. We are inhibiting this first and three phase by using potassium channel blockers. We are inhibiting this second phase by using calcium channel blockers. So these are all the mechanisms of actions of antiarrhythmics. You can see here, class 1, class 2, class 3, class 4. The class 1 drugs are sodium channel blockers. Class 2 drugs are beta blockers. Class 3 drugs are potassium channel blockers. Class 4 are calcium channel blockers. As you very well know that class 1 drugs, sodium channel blockers, potassium channel blockers, calcium channel blockers. How these beta blockers are helpful here is, I told you one of the reasons for tachyarrhythmias is excess activation of sympathetic nervous system. So sympathetic nervous system means we are using beta blockers. Okay, that's why. So I don't want to go for drugs because as you have people told that most of the students are first year, second year, and mostly formerly recent freshers will be there. So I don't want to go for drugs here. I would like to discuss only about the disorders and the concept of treating the disorders. Okay. So move on to the next disorder. After arrhythmias, that is congestive heart failure. Also called as congestive cardiac failure. So what is this congestive heart failure? Congestive cardiac failure is the heart is not able to pump sufficient blood to various parts of the body. Since from the beginning we are telling the basic function of the heart is pumping of blood for the supply of oxygen nutrients to all parts of the body. But congestive heart failure means the heart is not able to pump sufficient blood. Please remember, you should not say heart is not able to pump the blood. Heart is not able to pump the blood means heart is not working. Heart is died. Person is died, that indicates. But congestive heart failure means heart is not able to pump sufficient blood to various parts of the body. The heart is not able to meet the demands what raised by the various parts of the body. As a result, blood supply decreases to various parts of the body. Heart is pumping the blood, but not sufficient blood. The heart is not able to meet the demands what raised by the various parts of the body. The heart is not able to pump sufficient blood to various parts of the body called as congestive heart failure. Then how can you treat this condition is, so please listen here, there are two words, 2 points you have to understand. Heartbeat. Always heartbeat, heart contraction will have two properties, 2 dimensions. Let us hear. Heartbeat, heart contraction will have 2 properties. One is the number. Number means how many times. Next is force, with how much force. Listen carefully, understand carefully. There are 2 words here. Heartbeats, number of heartbeats, how many times heart is beating. Next is force of contraction, with how much force heart is beating. With how much force heart is beating. One is number and there is force. What is the problem happening in congestive heart failure? Heart is not able to pump sufficient blood. The heart is receiving the blood is present in the chambers of heart, but heart is not able to dump out. The heart is not able to pump out the blood to various parts of the body. For that, we require force of contraction, but not number of contraction. A simple example, you take a water into the syringe. You take a water into the syringe. Syringe is having water. Water, in order to come out of the syringe, you just touch it. Touch the knob. Touching is called as number. Just you smallly touch. That is number. But water to come out of the syringe, we should apply pressure. That is called as force. Without force, if you touch, also no use. What do you call force? So that's what in the CHF we require force of contraction. So in the treatment of congestive heart failure, we are using drugs which increase the force of contraction, like your cardiac glycosides, digitolis, sympathomimetics, phosphodiesterase inhibitors. I don't want to go for drugs, just I'm telling you the mechanistic approach. So now I hope you understand the disorder which is related to the number of contractions, number of heartbeat is arrhythmias. Arrhythmias means number, decreased heartbeat, increased heartbeat. The disorder related to the force of contraction is congestive heart failure. Let us move on to the third disorder, as everyone knows that is atherosclerosis. So what is this? Atherosclerosis. And I hope you all know that atherosclerosis means deposition of cholesterol or deposition of any lipid related material in the coronary blood vessels. In the beginning itself, I told you there are two types of blood vessels, coronary blood vessels and peripheral blood vessels. Coronary blood vessels supply blood to the heart. Peripheral blood vessels supply blood to the various parts of the body. Atherosclerosis means cholesterol or lipid related materials like triglycerides, lipoproteins accumulate in the coronary blood vessels and they will stop the supply of blood to the heart. That is called as atherosclerosis. So atherosclerosis means deposition of lipids or any lipid related materials like cholesterol, triglycerides, lipoproteins in the coronary blood vessels. As a result, blood supply to the cardiac muscle, as a result, blood supply to the muscle of the heart, myocardium will be decreases. That is called as atherosclerosis. If you are not treating this atherosclerosis properly, if you are not taking proper care about atherosclerosis, what happened? Blood supply to the heart decreases. Slowly, persons develop pain in the chest. That pain in the chest is called as angina pectoris. Those things I'll tell you next. Okay. And if you see this atherosclerosis, there are two major reasons for atherosclerosis actually here. What are those is, so because of disturbance in the balance and homeostasis. There's a disturbance between synthesis and metabolism of cholesterol. Actually, in our body, the cholesterol synthesis takes place by the enzyme HMG-CoA reductase. Probably what I have studied in the biochemistry. Cholesterol synthesis. The major enzyme involved in the synthesis of cholesterol is HMG-CoA reductase. And the enzyme for the metabolism of cholesterol is lipase, lipoprotein lipase. When these two enzymes are balanced, when these two enzymes are good, no problem. But atherosclerosis occurs because of disturbance in the balance, disturbance in the homeostasis. The activity of this enzyme will be more synthesis of cholesterol in the body, or decreased activity of this enzyme, so there is no breakdown of cholesterol. Anything. The persons can develop atherosclerosis either because of increased synthesis of cholesterol or because of decreased metabolism of cholesterol, increased activity of HMG-CoA reductase or decreased activity of lipoprotein lipase. So that the atherosclerosis majorly drugs used are HMG-CoA reductase inhibitors called as statins, lipoprotein lipase activators called as fibrates, clofibrate, fenofibrate, gemfibrozil. Next, let us come into the fourth disorder related to cardiovascular system, that is angina pectoris. So everyone knows that angina pectoris means chest pain, the pain in the chest. Always angina pectoris pain in the chest will happen because of imbalance between oxygen demand and oxygen supply. The major reasons for angina pectoris is increase in oxygen demand or decrease in oxygen supply. So angina pectoris means the pain in the chest pain. The people are having chest pain because of insufficient blood supply, insufficient oxygen supply to heart muscle myocardium. Why those things are happening is because of increase in the oxygen demand or because of decrease in oxygen supply. When we observe increase in the oxygen demand is when we have a exercise, when we have a more exercise. When we do any exercise, any physical activity, automatically the demand for oxygen will be increases. That's why you should not do exercise more also at a time. Sometimes you've seen in the newspapers and news channels, some people suddenly died, collapsed in the gyms while doing exercise. Because when we do exercise, the demand for oxygen in the body will increases. So when it is not supplying enough blood to the heart muscle, the pain in the chest will happen lead to angina pectoris. Even you can see some of the police selections, constable elections. I mean, is observed some running race competitions. Within 5 minutes, 5 kilometers running. Likewise, the people suddenly fall down because they keep on running. The more physical activity lead to the more demand for oxygen. Sudden failure of circulatory system takes place. Another thing is increase in heart rate. Yes or no? If heart rate increases, heart rate means what? Heartbeat is more. Heartbeat is more, and what? Heart is working more. When the heart is working more, heart requires more oxygen. The demand for oxygen will be increases. Next, the other reason for angina is decrease in oxygen supply. Why? Why the oxygen supply decreases? Because of vasoconstriction, right? If the blood vessels are constricted, oxygen supply decreases. Because of deposition of lipids, as I told you, atherosclerosis. If the lipids are accumulated, the blood supply to the heart decreases. Next, deposition of clots. Clots are formed, blood clots. Platelet aggregation. Platelets are blood cells, circulating elements of blood. One platelet adhere to another. All will form the aggregates of platelets. They will obstruct the flow of blood to the heart. So these are all the various reasons for angina pectoris. So remember, angina pectoris is chest pain, pain in the chest due to decreased insufficient blood supply to the cardiac muscle. That angina pectoris occurs because of increase in oxygen demand or because of decrease in oxygen supply. The increase in oxygen demand is because of more physical exercise, increase in the heart rate. Decrease in oxygen supply is because of coronary artery disease. I told you the coronary blood vessels supply blood to the heart. The coronary artery disease happens because of vasoconstriction, accumulation of lipids, deposition of clots, platelet aggregation. But based upon the reasons why this angina pectoris is coming, the angina pectoris is divided into 3 types: stable, unstable variant. So remember, stable angina pectoris means the plaques formed are, the cholesterol formed are stable in nature. I told you one of the major reasons for angina pectoris is deposition of cholesterol, formation of plaques. If the plaques formed are highly stable, that is called as stable angina. I hope you can see here. Stable. The plaques formed are highly stable. So unstable means the plaques formed are not stable, rupture takes place, erosion takes place, and they will release into blood vessels. They will combine with the clots and platelets also. This is called as unstable. So variant means from the C, vasospasm. The blood vessel is constricted like this. Ultimately what? This is the coronary blood vessel. Here it is a heart which supply blood to the heart. In all angina, what happens? In all angina, what happens? Blood supply to the heart decreases. So stable means the plaques, cholesterol deposits formed are stable like this. They adhere to the walls of blood vessels. The plaques are highly stable. Unstable means what? These plaques only ruptured, break, erosion takes place, release into blood vessels. They will combine with the clots and platelets. The variant means V stands for vasospasm because of vasoconstriction. Ultimately, because of all these reasons, blood supply to the heart decreases, chest pain will come, angina will come. Is it clear? But Depending upon the reason, we classified angina into 3 types. So that based on this only you can say this, what kind of drugs are used for angina pectoris also, right? What kind of drugs are used to treat angina? One of the reason for angina is increase in heart rate. So we are using drugs which decrease the heart rate like calcium channel blockers, beta blockers. So next, what are the reasons for decrease in oxygen supply? Vasoconstriction, we are using vasodilators. Next, drugs used in the treatment of atherosclerosis like statins. Next, anticoagulants, thrombolytics. Next, antiplatelet drugs. So in the black color I mentioned with reasons. In the green color, what class of drugs are helpful? So increase in heart rate is a reason. So that we are using drugs which decrease the heart rate, calcium channel blockers, beta blockers. So vasoconstriction can be treated by vasodilators. The deposition of lipids can be treated by drugs used in atherosclerosis, especially statins. The deposition of clots will be avoided by using anticoagulants, thrombolytics. The platelet aggregation will be inhibited by using antiplatelet drugs. Finally, remember, this is the relationship between one condition to other condition. Am I right? First is atherosclerosis. Deposition of lipids in the coronary blood vessels. Blood supply to the heart decreases, leads to coronary artery disease. So coronary artery is not able to supply blood to the heart. If this coronary artery disease happens, blood supply to the heart will be decreases, pain in the chest will come, called as angina pectoris. If angina pectoris is there for a long time, there is a less oxygen supply to the heart muscle for a long time, the complete myocardium will die. There is a death of the heart muscle called as myocardial infarction, called as a heart attack. We are using the word heart attack. Heart attack means a complete death of the myocardium. So atherosclerosis, deposition of lipids in the coronary blood vessels lead to coronary artery disease. The coronary artery is not able to supply blood to the heart, lead to angina pectoris, pain in the chest. If angina pectoris is there for a long time, there is a less oxygen supply to the heart muscle. When we don't have an oxygen supply to any muscle for a long time, the muscle will die, the myocardium will die. The death of the myocardium called as myocardial infarction, which is called as heart attack. So coming to the last disorder, we all know that the very commonly observed disorder in the society, that is hypertension. The increase in blood pressure called as hypertension. The normal blood pressure is 120 by 80 mm of Hg. So greater than or equals to 140 by 90 mm of Hg is considered as beginning stage of hypertension. So to understand this hypertension, what are the reasons for hypertension? You people have to know some definitions related to this blood pressure. If you understand all these things, you can easily understand what are the reasons for hypertension. First of all, I mentioned you hypertension means increase in blood pressure. Actually, what is blood pressure? Listen carefully. What is blood pressure? Is the pressure exerted by the blood on the walls of blood vessels. Yes or no? When the heart pumps the blood, the function of heart is pumping of blood. When the heart pumps the blood will enter into blood vessels. That time the blood will exert some pressure on the walls of blood vessels, that is called as blood pressure. Blood pressure means it is the pressure exerted by blood on the walls of blood vessels. When the heart pumps the blood flows through the blood vessels, right? That time the blood will exert some pressure on the walls of blood vessels. That pressure is called as blood pressure. Here, the blood pressure depends upon some parameters. The one is cardiac output. The cardiac output means we all know that it is the total volume of blood pumped by the heart per 1 minute. Cardiac output means it is the total volume of blood pumped by the heart per 1 minute. It depends upon two parameters. One is heart rate, another one is stroke volume. Heart rate means number of heartbeats per minute, which is 72 beats per minute, as you know that. Stroke volume, the volume of blood pumped by the heart per 1 heartbeat. See here, per 1 minute, how many times heart is beating? When one time heart is beating, how much blood is pumped? Heartbeat is number of heartbeats per minute. Stroke volume is when one time heart is beating, how much blood is pumped. When you multiply together the heart rate and stroke volume, you will get cardiac output. The cardiac output means the total volume of blood pumped by the heart per 1 minute. It is calculated by heart rate into stroke volume, 72 into 70, 5040 ml, approximately 5 liters. The next, another word is peripheral vascular resistance, PVR. Means it is the resistance offered by peripheral blood vessels for blood flow. When the heart pumps the blood vessels, what have? Peripheral blood vessels, right? These peripheral blood vessels offer some resistance for the flow of blood. When the heart pumps the blood, these peripheral blood vessels offer some resistance for the blood flow. That resistance is called as peripheral vascular resistance. Finally, we are calculating the blood pressure is a product of cardiac output into peripheral vascular resistance. How will you calculate? How will you determine the blood pressure is? The blood pressure is a product of cardiac output into peripheral vascular resistance. The cardiac output is calculated by heart rate into stroke value. Now, finally, what is the reason for hypertension is? The hypertension means increase in blood pressure. The reason for increase in blood pressure is increase in cardiac output as increase in PVR. What is the reason for increase in cardiac output? Maybe increase in heart rate or increase in stroke value. What is the reason for increase in PVR? When the peripheral vascular resistance is more, when the resistance offered by blood vessels is more, when we have a vasoconstriction. So try to understand the hypertension means increase in blood pressure. There are two reasons for increase in blood pressure. One is increase in cardiac output or increase in PVR. The increase in cardiac output observed because of increase in heart rate or because of increase in stroke value. The increase in PVR, increase in peripheral vascular resistance, when the blood vessels offer more resistance for the flow of blood, when we have a vasoconstriction. So overall, this is what you can see. These are all the various and different reasons for hypertension. So increase in cardiac output, increase in heart rate, increase in stroke value, increase in force of contraction, vasoconstriction. And what are all the reasons for the hypertension is? The scientists have investigated and identified that these are all the reasons may be involved in the development of hypertension. So one is more activation of RAS system, renin-angiotensin-aldosterone system, more activation of sympathetic nervous system, more activation of L-type calcium channels, excessive vasoconstriction, the excessive fluid and sodium retention. As everyone knows that RAS system is there in our body, sympathetic system is there in our body, calcium channels are there in our body. RAS system, sympathetic nervous system, calcium channels, all are increasing the blood pressure whenever a person is having decreased blood pressure. Remember carefully, all are increasing blood pressure whenever a person is having decreased blood pressure to maintain homeostasis, to maintain normal blood pressure. That's what I'm telling you. Disorder means altered function, either increases or decreases. Something is altered inside the body. Blood pressure is normal. We have a blood pressure. Every human being have a blood pressure, but blood pressure increases. Something system is altered, excessive or decreased. What are those is the more activation of RAS system, more activation of sympathetic nervous system, more activation of calcium channels, excessive vasoconstriction, excessive fluid and sodium retention. So that in the treatment of hypertension, we are generally using the drugs called as drugs inhibiting RAS system, AC inhibitors, angiotensin II blockers, drugs inhibiting sympathetic nervous system, alpha blockers, beta blockers, calcium channel blockers, vasodilators, as well as diuretics. Okay, here we don't have that much time to discuss all the systems in detail because I have allotted with 2 hours. In that 2 hours, I would like to give you what maximum is possible to understand the things I'm giving you, just brief lining of all the disorders. So finally, have a look onto this. Once I'm explaining you the disorders of cardiovascular system here. So please listen. One is arrhythmias, increased or decreased heartbeat, tachyarrhythmias, broad arrhythmias, most of the patients are having tachyarrhythmias. So the reasons for tachyarrhythmias, we told bradyarrhythmias. The mechanisms of these antiarrhythmics include class 1, class 2, class 3, class 4. To heart failure, the heart is not able to pump sufficient blood. We need to increase the force of contraction. So atherosclerosis, deposition of lipids, cholesterol in the coronary blood vessels, blood supply to the heart will be decreases. Angina pectoris, pain in the chest pain due to insufficient blood or oxygen supply to the cardiac muscle because of increase in oxygen demand or decrease in oxygen supply. So hypertension, increase in the blood pressure. So the reasons for increase in blood pressure, I told you, these are all the various reasons for increase in blood pressure. So finally, have a look onto this. Just I would like to brief out what I discussed since from the beginning here within just 2 minutes. Have a look onto this, all these things. I discussed here about electrophysiology of cardiovascular system as well as cardiovascular disorders. Just I will brief out all the things within just 2 to 5 minutes. Have a look onto this. Afterwards, I will show you some 2 videos, then we'll close the session. The first one, impulse generation or impulse, the first point you should know is impulse generation or action potential generation in the cardiac cell. I'm telling you, impulse is nothing but action potential. How cardiac cell will generate the impulse or action potential is, I told you, first there is a resting stage, resting membrane potential, -90, opening of sodium channels. Then sodium channels will be closed, potassium channels will be open, then calcium channels will be open, calcium channels will be closed, opening of potassium, activation of sodium potassium ATPase. There are 5 phases, phase 0, 1, 2, 3, 4. Phase 0, sodium channels, 1 potassium channels, 2 plateau phase, no change in the potential calcium channels, phase 3 potassium channels, phase 4 sodium potassium ATPase. This impulse generation usually takes place in the SCA node, which is having automaticity, which is called as a pacemaker. SCA node to atria, AV node, bundle of his Purkinje fibers, ventricles, ventricular contraction, heartbeat. It is nothing but ECG. In the ECG, first line denotes SCA node, P wave because of atria, next line AV node, QRS is because of ventricular depolarization, T wave is ventricular repolarization. So coming to this flow of blood in the chambers of heart, superior vena cava, inferior vena cava will carry blood into the right atrium. From this right ventricle, lungs, left atrium, left ventricle pump the blood. Whenever impulse generation takes place in the SCA node, from this it will reach to atria. Atria undergo contraction, pressure in the atria will increase. Opening of tricuspid valve, opening of bicuspid valve, blood will move from right atrium to right ventricle, left atrium to left ventricle. Then the impulse moves to ventricles. Ventricles undergo contraction. Ventricular contraction causes closing of tricuspid, bicuspid valve, opening of pulmonary valve, aortic valve. Blood will enter into lungs. Blood will reach to other parts of the body. So first disorder is arrhythmias. The irregular heartbeat, decreased or increased heartbeat, tachyarrhythmias, bradyarrhythmias. Most of the patients are suffering from tachyarrhythmias. For the tachyarrhythmias, we are using the drugs which decrease the heartbeat, which decrease the impulse generation. Sodium channel blockers, calcium channel blockers, potassium channel blockers. So next is a congestive heart failure. Heart is not able to pump sufficient blood. The blood is not able to come out of the heart. Blood supply decreases to various parts of the body. We are using drugs which increase the force of contraction. Atherosclerosis, deposition of cholesterol or any lipid-related materials in the coronary blood vessels. As a result, blood supply to heart will be decreases. So that we are using drugs which reduce the synthesis of cholesterol called as statins. Angina pectoris, the pain in the chest pain due to insufficient blood or oxygen supply to the myocardium. The 2 reasons are increase in oxygen demand or decrease in oxygen supply. So decrease in oxygen supply occurs because of cholesterol deposition, clots deposition, platelet aggregation, vasoconstriction. So that we are using vasodilators, anticoagulants, thrombolytics, antiplatelets, and statins. If angina pectoris worsens, continues for a long period of time, there is a prolonged lack of oxygen supply to myocardium, the death of the heart muscle will take place that lead to heart attack called as myocardial infarction. The hypertension means increase in blood pressure. The blood pressure means the pressure exerted by blood on the walls of blood vessels. Blood pressure is a product of cardiac output into peripheral vascular resistance. Cardiac output is a product of heart rate into stroke volume. The different reasons for hypertension are increase in the heart rate, increase in the stroke volume, increase in the cardiac output, the increase in peripheral vascular resistance because of vasoconstriction. The hypertension majorly happens because of the excessive activation of some systems present in our body like renin, angiotensin, aldosterone system, sympathetic nervous system, calcium channels, excessive vasoconstriction, excessive retention of fluid and water. Based upon this, we have different classes of drugs to treat hypertension. So this is my whole presentation about the cardiovascular system, the electrophysiology of cardiovascular system, and the brief discussion on the disorders related to cardiovascular system. So once again, I'm telling you, so myself, Dr. Nagarjuna, I'm working as a coordinator for GPAT cell in the Raipur. And we are running the one coaching institute called as Hyderabad Academy. We are providing the coaching for all competitive examinations in the pharmacy field for GPAT, NIPER, and other government examinations. And right now we are running the coaching in the online mode. We call as the online GPAT Academy also. And on this occasion, I'm thankful really once again, Rathai Garu, Srinivas Babu Garu, as well as Ashok Garu. And I given in the slide my WhatsApp number as well as my contact number, my mail ID also. If you have any doubts and queries, you can contact also freely. Mostly you prefer WhatsApp. If you want really, you can call also. So if you want, you can take it and you can just contact me along with your details. So we are always there to help you and to solve your doubts. And finally, I will show you some 1-2 videos by which we'll close the session. Then we'll go ahead. So all of you have a look onto this video, so you can understand somewhat. We have some realistic approach towards this generation.
Will your child win free education for life? Book a free coding class with White Hat.
Is it visible, Ashok? Okay. No?
Yes, sir.
The heart is essentially a muscle that contracts and pumps blood. It consists of specialized muscle cells called cardiac myocytes. The contraction of these cells is initiated by electrical impulses known as action potentials. Unlike skeletal muscles, which have to be stimulated by the nervous system, the heart generates its own electrical stimulation. In fact, a heart can keep on beating even when taken out of the body. The nervous system can make the heartbeats go faster or slower, but cannot generate them. The impulses start from a small group of myocytes called the pacemaker cells, which constitute the cardiac conduction system. These are modified myocytes that lose the ability to contract and become specialized for initiating and conducting action potentials. The SA node is the primary pacemaker of the heart. It initiates all heartbeats and controls heart rate. If the SA node is damaged, other parts of the conduction system may take over this role. The cells of the SA node fire spontaneously, generating action potentials that spread through the contractile myocytes of the atria. The myocytes are connected. Electrical impulses, calcium, they also adjacent cell and bring the membrane voltage of the calcium inside the cell.
So now you can just see this. Whatever we discussed in the impulse generation, have a look onto this. So this is the resting membrane potential. This is -90. This is threshold potential we call as -70. Have a look onto this.
These positive ions leak through the gap junctions to the adjacent cell and bring the membrane voltage of this cell up to the threshold of -70 millivolts. At threshold, fast sodium channels open, creating a rapid sodium influx and a sharp rise in voltage. This is the depolarizing phase. L-type or slow calcium channels also open at -40 millivolts, causing a slow but steady influx. As the action potential nears its peak, sodium channels close quickly, voltage-gated potassium channels open, and these result in a small decrease in membrane potential, known as early repolarization phase. The calcium channels, however, remain open, and the potassium efflux is eventually balanced by the calcium influx. This keeps the membrane potential relatively stable for about 200 milliseconds, resulting in the plateau phase, characteristic of cardiac action potentials. Calcium is crucial in coupling electrical excitation to physical muscle contraction. The influx of calcium from the extracellular fluid, however, is not enough to induce contraction. Instead, it triggers a much greater calcium release from the SR in a process known as calcium-induced calcium release. Calcium then sets off muscle contraction by the same sliding filament mechanism described for skeletal muscle. The contraction starts about halfway through the plateau phase and lasts till the end of this phase. As calcium channels slowly close, potassium efflux predominates and membrane voltage returns to its resting value. Calcium is actively transported out of the cell and also back to the SR. The sodium-potassium pump then restores the ionic balance across the membrane. Because of the plateau,
You understand? This is a resting threshold, opening of sodium channels, closing of sodium channels here, the opening of potassium, opening of calcium, only opening of potassium, restoring the resting by the activation of sodium potassium ATP. Okay, the last one I will show you, just 1-2 minutes video, then we'll close the session. Have a look on this conduction system in the heart.
I would like to tell parents, the kids who cannot sit at one place,
The cardiac conduction system consists of the following components. The sinoatrial node, or SA node, located in the right atrium near the entrance of the superior vena cava. This is the natural pacemaker of the heart. It initiates all heartbeat and determines heart rate. Electrical impulses from the SA node spread throughout both atria and stimulate them to contract. The atrioventricular node, or AV node, located on the other side of the right atrium near the AV valve. The AV node serves as electrical gateway to the ventricles. It delays the passage of electrical impulses to the ventricles. This delay is to ensure that the atria have ejected all the blood into the ventricles before the ventricles contract. The AV node receives signals from the SA node and passes them onto the atrioventricular bundle, AV bundle, or bundle of His. This bundle is then divided into right and left bundle branches, which conduct the impulses toward the apex of the heart. The signals are then passed onto Purkinje fibers, turning upward and spreading throughout the ventricular myocardium. Electrical activities of the heart can be recorded in the form of electrocardiogram, ECG, or EKG. An ECG is a composite recording of all the action potentials produced by the nodes and the cells of the myocardium. Each wave or segment of the ECG corresponds to a certain event of the cardiac electrical cycle. When the atria are full of blood, the SA node fires. Electrical signals spread throughout the atria and cause them to depolarize. This is represented by the P wave on the ECG. Atrial contraction, or atrial systole, starts about 100 milliseconds after the P wave begins. The PQ segment represents the time the signals travel from the SA node to the AV node. The QRS complex marks the firing of the AV node and represents ventricular depolarization. Q wave corresponds to depolarization of the interventricular septum. R wave is produced by depolarization of the main mass of the ventricles. S wave represents the last phase of ventricular depolarization at the base of the heart. Atrial repolarization also occurs during this time, but the signal is obscured by the large QRS complex. The ST segment reflects the plateau in the myocardial ventricle. This is when the ventricles contract and pump blood. The T wave represents ventricular repolarization immediately before ventricular relaxation.
I hope you understand. This line is corresponding to this SA node. This wave, P wave, is responding to this atria. This is representing your AV node majorly. And this QRS, this height is majorly representing your mass of the ventricles. And finally, this T wave, ventricular relaxation. So where the one ECG, one heartbeat will end, the another ECG will start once again. Likewise, cardiac cells are continuously generating the impulses, heartbeats, and ECG you can observe. Okay? So with this, I will conclude my session. So, okay.
Thank you, sir. Thank you very much. Thank you for your amazing lecture. It's really impressive. The way you have explained with colorful images. Enjoyed a lot. Simply superb, sir.
Thank you. Thank you.
Over to Pranati for question and answers.
Thank you, sir, for your wonderful and informative session. I request Tejasri to please unmute and ask the queries.
Good afternoon, sir.
Tejasri.
Good afternoon, sir. I'm Tejasri. And my doubt is atherosclerosis affecting to all the animals or certain animals?
Sure, something is happening. Okay. Great. What is your question? Atherosclerosis
Is only affected to certain animals or all the animals?
affected means I'm not getting actually. So mean to say that you want to say in the preclinical development.
Yes, sir.
So basically in the development of anti-atherosclerotic drugs, we are inducing this atherosclerosis condition to the animals. The most commonly responding animals are rats and rabbits we are using. So we have a surfactant called as a triton. So triton is a surfactant which increases lipid levels in the rats usually. That is experimentally used to induce atherosclerosis to the animals, but it is an acute model. Or we can go ahead for the high lipid diet to the animals also, or you can go for high carbohydrate diet to the animals also. We can use rats and rabbits. Yeah, definitely it will come, no issue. So
okay, sir, thank you.
Do not develop any drugs.
Sir, a doubt by Satyashree.
Yeah, tell me.
Is heart failure more common to men or women?
It's not like that, depending upon the ventricular capacity of the heart. So that's what in the heart, the pumping capacity of the heart is majorly because of the ventricles, majorly left ventricle. So based upon the presence of these calcium channels, contracting capacity, actin and myosin, the capacity, the pumping capacity of the heart is varying from one to others. But basically, to some extent, it is more in the women, you can say that.
And another doubt by Archana, sir. Is atherosclerosis genetic in origin or not?
Yeah, absolutely. Every disorder is a genetic only. There is no doubt about it. All disorders majorly happens because of genetical mutations only. So I told you in the beginning itself, atherosclerosis happens because of disturbance in the homeostasis and balance. So because of increased activity of HMG or decreased activity of lipase. So why in some individuals only we have more activity of HMG correctase, more synthesis of cholesterol is because of genetical manipulations only. Because everyone is having HMG correctase, the role of this enzyme is conversion of HMG correctase to mevalonic acid involved in the synthesis of cholesterol only. But in some individuals, we have more activity of this enzyme. That is because of enzymes. Nothing but enzymes are chemically proteins. The proteins nothing but formed from mRNA, nothing but from DNA. So when we have a DNA alteration, automatically you can expect change in the activity of the enzymes, the altered function you can expect. Not only for atherosclerosis, the very common reason for every disorder is genetical alterations only.
Okay, sir. Thank you.
Okay, over to Pranati.
Thank you, Tejasri. Now I request Ravishankar sir, Dr. P. Ravishankar Garu, HOD, Department of Pharmaceutical Analysis, Vignan Pharmacy College, to please speak few words. Sir, please.
Hello, can you listen me?
Yes, sir.
Okay. Hello, everyone. This is Professor Ravishankar, HOD of Pharmaceutical Analysis, Thank you so much for having delivered such an explicit topic, Dr. S. Nagarjuna Garu.
Thank you.
Okay. The topic, in fact, that you delivered, electrophysiology of CVS and CVS disorders was just awesome. Indeed, your educational skills are just explicit, exploding. So generally, for the students, this topic is this would be little bit chaotic, like bewildered, perplexed. But you have explained all the things assiduously and in explicable way that everybody could understand. So now, as a matter of fact, I have listened your presentation. I loved every minute of it. It just spot on. Okay. Okay. Our students also wants more of you, Nagarjuna Garu. You always feel like our college is a part of our family. Okay. Okay. Professor P. Srinivas Babu, Principal of Vignan Pharmacy College, and Dr. Ashok is right now on this online webinar along with me.
Yes.
On behalf of Vignan Pharmacy College and all of you, it is our honor to present Dr. S. Nagarjuna, Coordinator for Riper Cell Hyderabad Academy and Online GPAT Academy, with this explicit virtual certificate of appreciation.
Thank you for giving this opportunity. Yeah.
Okay, thanks a lot, sir. That's it. And thanks so much for using VPC YouTube channel and Zoom meeting. Okay, over to Pranati.
Thank you, sir. Thank you so much, Nagarjuna sir, for your wonderful session. Yeah. And I thank all the participants for their enthusiastic role in today's session. And I request your support should be continued in the same way for all the sessions. Thank you all.
Thank you.
Once again, thank you, sir. Nagarjuna sir.
Okay, thank you.
So thank you, sir. Thank you very much, sir. Thank you for joining. Thank you, sir.
Thank you, Nagarjuna sir.
Thank you, Ashok.
Thanks. Okay, thanks a lot.
Can I leave, Ashok?
Okay. No questions, sir. That's it.
Shall I leave? Shall I leave?
Yes, sir. Yes, sir.
Okay.
Okay. I request all the participants tomorrow join sharp 11 o'clock. Thank you, one and all.